Hey guys, well, here we are again, back on time at home, working virtually. Today we're going to be working on solving quadratics by taking square roots. And this is kind of an interesting topic because, I don't know if you guys remember this or not, but whenever you're working with solving quadratic equations, meaning that they have the second power raised, that means that we've got two solutions. Not one, but two. Okay, so here's what's going to go down, okay? I have n squared equals 7 as my first problem. And I'm actually using the homework assignment to do some of your notes. I'm just going to select some problems from the assignment itself. And what we want to do, we want to solve n squared equals 7. So I'm going to take the square root of both sides, because the inverse of squaring something is taking the square root. Now here's the thing that a lot of people forget. When I take the square root in solving an equation, n squared, if n squared is equal to 7, then they might have multiplied the positive root times the positive root, or the negative root times the negative root. And because of that, I have to put a plus or minus in front. Now, we know that the square root of n squared cancels out, and that just leaves you with n. But 7, now remember, 7's a prime number. I can't do anything with a prime number. When it's under the radical, it stays there. So my solution for this one's going to be plus or minus the square root of 7. And that's all she wrote. That's all there is to that one. Okay, but let's look over at number 2. Now, most of you know the square root of 64. But I'm going to work this out in the two-column method, like we learned yesterday, just to make sure that we know that method inside and out. Okay, so I've got plus or minus the square root of 64. And I know that the square root of x squared is x. Now, the square root of 64, I can simplify that. So I'm going to start with my two-column method. And I know that the lowest prime number that will divide evenly into 64 is 2. And it goes 32 times. And the lowest prime that goes into 32 is 2, and it goes 16 times. And the lowest prime that goes into 16 is 2, and it goes 8 times. And the lowest prime that goes into 8 is 2, and it goes 4 times. The lowest prime that goes into 4 is 2, and it goes 2 times, and 2 is prime. So, Kayamishi, I will go no further. Okay, now, I'm going to circle my pairs of 2's because I am doing square roots. If I was doing cube roots, I'd do groups of 3 of a kind. I'm only doing pairs. So I've got a pair of 2's, another pair of 2's, a third pair of 2's. So that's going to be 2 times 2 times 2. So x equals plus or minus 2 times 2 is 4 times 2 is 8. Now, think back on this. If I had negative 8 times negative 8, that'd give me positive 64. If I had positive 8 times positive 8, guess what? That'd also give me 64. Okay, now let's go down to number 5, because number 5 is not a perfect square. Okay, so I'm going to take the square root of both sides. Square root of n squared equals plus or minus, because I have my two solutions, the square root of 24. Now, if I take that 24 and I do the two-column method, I know that 2 goes into 24 12 times, 2 goes into 12 6 times, 2 goes into 6 3 times. 3's prime. Kayamishi, I will go no further. Okay, so n equals plus or minus the pair of 2's that I have here. And I had a 2 and a 3 left over. Both of those go underneath the radical, 2 times 3. And so n is equal to plus or minus 2 times 2 is 4, square root of 4 is 2 from here, times the square root of 6. Now, check out number 7. 7 has a little more going on. So I am going to subtract 7 from both sides. Okay? That gives me x squared is equal to 64 minus 7, which would be 57. Now, next step, of course, take the square root of both sides and put the plus or minus in front. Now, thinking back on 57, 57 is kind of an interesting number. Is it prime? Is it not? Well, let's see. 57. I don't believe it's divisible by 1 or by 2. Would 57 divide by 3? 3 will go into 5 1 time, and then to 27 9 times. So I've got a prime number, Kiamichi. I can go no further because 19 is prime. But guess what? Guys, I've only got one of each of these. 1 3, 1 19. There's no pairs. And so they both go back under the square root. And 3 times 19 takes me back to 57. So my solution is going to be x equals plus or minus the square root of 57. All right, number 8 is a very similar problem. I want to do this one too with you guys just to make sure we're kind of on the right track. So I'm going to subtract 9 from both sides. N squared equals plus or minus 4. Or, sorry, equals 4. I'm getting ahead of myself. Okay, now I'm going to take the square root of both sides. And when I do that, that's where I add the plus or minus. So n is equal to plus or minus the square root of 4, which would be plus or minus 2. All right. So this does go on a little bit farther. We've got some problems that get a little more complex as we move farther along. Say, for instance, if I was on number 15, okay? You might use this actually when you get to 13, 15, 16. Okay, I've got 36x squared equals 4. I need to get the x squared by itself first. So I'm going to divide both sides by 36. These cancel out over here. I'm left with x squared equals 4 over 36. Now, I'm going to take the square root of both sides because I'm solving for x squared. And that gives me a plus or minus in front. Now, the way I'm going to handle this is I take the square root of the top and I take the square root of the bottom. So, square root of 4 is 2. And the square root of 36 is 6. And 2 over 6 simplifies to 1 over 3. So plus or minus 1 over 3. Okay. Go on a little bit farther. Get down to number 21. And whoa, man. They've done all kinds of stuff for us here. First thing I want to do, I want to subtract 5. And then that gives me negative 9x squared equals negative 45. Now, negative 45 is not a perfect square. And so I'm going to handle it a little differently than I did the last example. I'm going to divide both sides by negative 9. And then x squared is equal to, well, now negative 9 divides evenly into negative 45. It'll go in 5 times. So then I want to take the square root of both sides, be a plus or minus. And I can't take the square root of 5 because it's prime. So we just leave it as plus or minus the square root of 5. Okay, one more example from the back page. Let's look at number 25. Okay, first step. I've got 344. I'm going to subtract 8 from both sides. Now, if I do that, 7n squared is equal to 344 minus 8. That would be 336. Now, I want to divide both sides by 7. Now, I'm not sure. Is 7 going to go into 336? N squared equals, okay, 7 would go into 28 4 times. 28 from 33 is 5. Bring down the 6. 7 will go into 56 8 times. So n squared is equal to 48. Alright, well, I need to take the square root of both sides and put the plus or minus in front. So n is equal to plus or minus the square root of 48. Well, let's go over here and do our 2-column method again. So 2 goes into 48, 24. 2 goes into 24, 12. 2 goes into 12, 6. 2 goes into 6, 3. Cross out everything that's not prime because I got to 3, it's prime. So Kaimishi. I've got 2 pairs of 2's, 2 and 2. So I've got 2 times 2 times the square root of 3. That gives me n equals plus or minus 4 times the square root of 3. Okay, so I hope this video helps. If you need to, rewatch this a couple of times. That may help you out a little bit. But there's several examples here. And then I will be available during the math office hours. So be sure and check in then. I'll be available by Zoom. And I'll put the link in Schoology. Talk to you later, guys. Hope you have a wonderful Thanksgiving. If you are receiving this assignment Friday, well, everybody should be receiving it Friday. So, according to the new school plan, so we'll go accordingly from there. There will probably be another assignment that you guys need to take care of Monday and Tuesday. All right, have a great day. I will talk to you later.